Okay, so if you're not familiar with the CNCF, it was originally established in 2015 to host Kubernetes. It's now expanded to host a whole ecosystem of other cloud-native projects, things that are focused on containers, serverless computing, WASM, and it's also been a platform of choice for building and deploying AI applications. In a nutshell, our mission is to make cloud-native computing ubiquitous. And that is.
So we have Kubernetes everywhere. So we started in trading, and Pokemon was the first application, but you also have it in ships, you have it in banks, you have it in healthcare, you have it in transmission grid and electrical systems. You have it even in F-16 airplanes. So all these systems are critical in terms of, yes, we need security here. And this cannot necessarily be connected directly to the cloud.
Und Hybrid-Cloud sein. Also dort ist die Aussage, dass wir halt diese Umgebung haben wollen, nämlich öffentliche Clouds, private Clouds oder Clouds, die halt beides benutzen, also Clouds, die halt bei mir im Rechenzentrum laufen, Clouds, die halt öffentlich sind. Und dazu gehören Best Practices wie Container, Service Meshes, Microservices, Immutable Infrastructure und deklarative APIs. Die unterstützen alle diesen Ansatz. Und da finde ich halt spannend, dass dort Container drin stehen als Technologie, was zweifellos irgendwie mit dem Thema Cloud Native assoziiert ist. Die stehen da drin, aber es steht zum Beispiel Kubernetes da nicht drin als eine Infrastruktur. Dafür stehen da Microservices drin.
What Kubernetes is in some sense, but I think that the most important thing that you need to know about Kubernetes is also that it's a declarative resource-centric API, which means that you kind of declare your target state, and Kubernetes' task is to actually get the current state more closer to the target state. Well, and you also can write your own controllers. This is what I mean. So you can also write an application that performs exactly the same loop, and this is quite nice. But there's an even more advanced concept that is based on the controller pattern, which is the operator pattern. And the question actually is really here how you can encapsulate your operational knowledge into something which is executable. And this works. I like this this quote here, is that actually an operator is a Kubernetes controller that really understands two domains. So one is, of course, Kubernetes, but the other one is kind of a specialized, maybe business domain, something like, for example, Prometheus knows about the observability domain, and operator combines both of them. So actually he has the knowledge, but actually tells then Kubernetes actually what to be done, and can automate all these tasks that are actually not at the heart of Kubernetes, but outside, but you can benefit from the whole machinery that Kubernetes offers. So actually for our task here, this operator is just a controller plus a so-called custom resource definition. What a custom resource definition is, we see in a second. Actually, this kind of definition is a little bit fuzzy, of course. Some people don't agree with that, but actually this is the working assumption for our book here. And a custom resource definition actually is actually encapsulates or offers the configuration of your specific domain. So actually if you're a Java developer, for example, you can think about a custom resource definition as a Java class, so it's a type definition.
Man kann dann trotzdem komplexe Logik umsetzen.
Ja, also auch gerade Prozesse, also eine Ressource kann durchaus auch ein Prozess sein. Ne? Also,
there are tons of other resources that are going around that we are not going on, of course, not into detail of that one, but everything, at the end, everything goes around your code. So your code is running within a container. You describe how your code should be run and how it interconnects to the outside world. The control plane is also responsible to distribute all this workload to the different nodes. And the central element in Kubernetes, you know that it's a pod. A pod is kind of a higher level abstraction of a container. So a pod can contain one or more containers. And these containers can talk to each other, either via network or, if you configure it, also via a disk, a volume. And these containers are kind of opaque, so everything what is running in the container stays in the container, and you can put anything what you want in these containers. And around this abstraction, so pod, you described a pod with a YAML file, so we focus this time on the controller pattern and the operator pattern. So first on the controller pattern, to understand the controller pattern or to think about what what the question actually, the controller pattern helps you to get from a current state to a declared target state. So this is, as I mentioned at the beginning, this is kind of at the heart of Kubernetes to exactly make this reconciliation. And if you think really, so Kubernetes is really a distributed state manager. So it really needs to manage the state on multiple distributed nodes or in the cluster. And actually all Kubernetes, not all, but actually the main thing that Kubernetes does is really to make the actual state, or the state that is observed, more closer to the declared target state. So the target state you declare in these resource files that you have seen, so the YAML files here. And this is a kind of an endless cycle that goes on and on. So first of all, you observe. So observe means that your controller is listening on events that the API server distributes to everybody who is interested in certain type of events. Then these events are analyzed and compared to the configuration in the resource files. And if they are the same and if they fit, then everything's fine, nothing needs to be done. But if there's a delta, then some action needs to be done. And this works like, as I said, the API server sends over events to a controller. The controller analyzes and then acts also via the API server. The API server then is responsible for talking to the node components. So these
Eigentlich, ich behaupte halt, dass Microservices nur eine weitere Form der Modularisierung sind und einem nicht helfen. Also Microservices sagen nur, wie ich mein System aufteile, technisch in Docker-Container. Die sagen nicht, was ich dort aufteile, also die Fachlichkeit. Deswegen ist es ja, glaube ich, so wichtig, beide Aspekte zu betrachten. Deswegen sind beide Aspekte auch
necessarily easy to find. As I said earlier, they are the what, not the how. And if you use the Steve Jones model, it's not really about who and why either. Just start with the what. What are these things? So a capability, I looked up Wikipedia, they have a definition. It says, a capability is the ability to perform or achieve a certain action or outcome. So we already talked about this, so I don't know. But one thing to remember here is that this is very structural. It doesn't say anything about movement or actions, or because you need other models for that, but it's a static picture. And it's often hierarchical. You start with a few on the top and break it down to bits. Okay, this doesn't work anymore, let's cancel it, which they, by the way, never do, because of sunk cost fallacy, but still. So that's the idea. If you model around the most stable thing, you are in a much better place. So a capability, let's define it a bit then. It's stable, as I said. It's cohesive, it's not this classical term, but it's cohesive. Another quote, a business capability is a particular ability or capacity that a business may possess or change to achieve a specific purpose or outcome. It's based on outcomes, by the way, right? Not outputs, which is good. So this is, you can think of yourself, without making this magic, business capabilities, think of it, you have capabilities to do stuff, right? You have capabilities to create art, for example. You have capabilities to design the perfect IT system or the perfect domain model. You got abilities to do stuff, right? This is what capabilities are. It's somebody even claimed that competence would actually be a better word. But capabilities is what we use, though.
So this is what we ended up with. And why did we end up with that? Well, it's because it all started here, right? It all started with the sharing of data. So now we can start to define kind of what a service is. But first of all, what a service is not. A service is not something that is just kind of something with functionality, like a validation or a calculation or something like that. That is what a function is, right? That's kind of the definition of what a function is. It's not something which gives you CRUD operations on data, just changing records. Yeah, that's what a database is. And really importantly, if you just put HTTP on top of a database, just sprinkle this kind of magic ASP.NET Core magic dust over a database, it doesn't suddenly make it a service, right? Contrary to a lot of the articles that appeared on the web a while ago, it doesn't suddenly make it a service, right? All you've done is, it's still a database, you've just changed the technical entry point from database connection to HTTP. A service is the technical authority for a specific business capability. And really importantly, all data and business rules reside within the service, right? You can think of it as bounded context, if you like, if you're kind of an Eric Evans domain-driven design fan.
So this is what a developer cares about, well, especially in a monolith architecture, quite common. And this is called this typo tactical design in the domain-driven architecture world. And this is called a service. This is what probably most of you know, right? Looks familiar, right? So now, the most part today, we will not talk about the left part. We will talk about the right part, that's strategic design. Strategic design is complementary to the tactical design. Here's the typo fixed, by the way. So, and these two parts, tactical design and strategic design, are the fundamental pillars of domain-driven design. So what does strategic design? Strategic design describes the relationship between services in different maybe subdomains in a big picture domain. So big picture domain could be e-commerce, could be automotive, could be insurances, could be government, health, or whatever context you are working in.
Pictorial representation, and this will give you a good idea. So the first one is the pod implementation that, remember I talked about the smallest unit of deployment is a pod in Kubernetes. And a pod can consist of multiple containers. So how does networking work in that case? So here you can see C1 and C2 are two containers within a pod, but they share a common network namespace. And that common network namespace gets an IP address assigned. So Kubernetes then takes care of making sure that it is forwarding the packet to the appropriate container when the packet is hitting that container, hitting the pod's IP address. Because each of these containers will have separate ports exposed against the shared IP against which you are trying to make that request. Now, from a pod to pod and pod to node perspective, remember we talked about some of the fundamental requirements where each of the pods will have their own IP address, and then each of the nodes themselves will have their IP address so that the pods and the nodes can talk to each other. You create a bridge in this case, which is handing out the pod's IP address, just like in Docker's case. But the routing functionality of communicating between the two containers or two pods is all taken care by your fabric itself. You do have constructs like service IP within Kubernetes, which can front-end all of your pods. All right, so now we have the Kubernetes networking. So we talked about, there were fundamental differences from a model perspective because of which the CNI or the container network interface was used in the Kubernetes environment. And these are kind of the three fundamental that I captured. The first one being that all containers can communicate with each other without NAT. Remember in the Docker model, we had the IP table rules, which is used for all the L3 traffic. Well, in Kubernetes case, they say, well, we don't like any NATing. What that means is that your pods within Kubernetes need to have a routable IP address, or your fabric itself should be capable of routing the container traffic. Which
workload like a desktop. If I ask people what is a desktop, I get different answers. And this is a summary of all the answers I've gotten so far. Classic desktop, so yeah, it's a Windows. No, it's a Linux. Which kind of Linux? GNOME, KDE, I personally, but everybody can use it. It must be a web application. The design must be changeable. This is part of the architectural design on Kubernetes. So this is a typical Kubernetes setup. You have a load balancer at the top. Then you have a login. This is more or less done by an ingress.
What a container image really is. When you run a command such as podman build or docker build, what is the artifact that is generated that you can then use to create a container based off of, right? So when you run podman build, there is this thing called container image that is being created, and then you use that to run a container, right? So I'm going to dive deeper into this particular artifact that we call the container image. So we want to create an image that is functionally equivalent to this Docker file, this container file, and it should generate the same output as when you pass in this container file to a command like docker build or podman build, right?